Okay, so the last time we stopped after talking about the monitoring and management of a nutrient solution of an hydroponic system, how to clean it, and how to manage it in the best possible way using filters in order to avoid the dysfunction of the pumps. And today we will start talking about we'll start talking about how to effectively prepare a nutrient solution. So let's make again another introduction. So first of all, you know that on the market there are several products that are already available for the preparation of a nutrient solution. You can have commercial formulations that may be of two different types. There are dry fertilizers and liquid fertilizers, as you can see on the right part of the screen. And the main difference between these two types of fertilizers is that usually liquid fertilizers are more expensive because they are more bulky, so they occupy more space, and so for transportation they require higher amount of energy and space. And also they are less stable in comparison to dry fertilizers because the salts inside the liquid preparation can react and precipitate, and they will no more be available for the plants. These kind of fertilizers, however, are always more expensive than the personalized formulation solution. In this case, the nutrient solution, it is not prepared by a company that gives you a product of a very concentrated nutrient solution that you have just to dilute in your tank, and it's already it's ready to go. Instead, if you are using a personalized formulation, you will be starting from single salts. So, for example, ammonium nitrate, magnesium nitrate, potassium sulfate, and whatever. And you mix these different fertilizers in order to fine-tune your hydroponic nutrient solution and give to the plant all the nutrients they need. Of course, to do so, you need to make some calculations, because starting from the single salt, you will have to calculate the correct amount of each element that must be provided to your plant. So in this case, you have two different approaches depending on if you're starting from a commercial preparation or if you're preparing it by yourself starting from the single salt. If you're using a commercial preparation, you will have your concentrated nutrient solution that is already prepared by the company in the correct ratio between the elements, and you have just to dilute it in your tank until you don't reach the electroconductivity that you require for your crop. To do so, you will do, if you remember, we will do exactly as we did for the pH, as we explained last week. So you will have to take 1 liter sample of your nutrient solution, gradually adding the fertilizers from the company until you don't reach the electroconductivity value that you want, and then you just multiply the quantity of fertilizers that you used for 1 liter for the total amount of liters that you want to prepare. Instead, if you are starting from the single salt, you have to do a lot of calculations because there are several salts that you can use, and it may happen that two salts contain the same element. For example, magnesium nitrate and calcium nitrate. Then both provide nitrate, and so you have to take into account every time you add magnesium nitrate, you are not adding only magnesium, but also nitrate. We already explained the empirical approach that is the same as for the pH. And now we are talking about the mathematical approach. So as you will know, the fertilizers, when you buy, for example, ammonium nitrate, on the label, there is written the title of the fertilizer, which corresponds to the amount of that element that is present in these salts. For example, if a fertilizer has a nitrogen title of 10, it means that there are that in 100 parts of fertilizers, there are 10 parts of nitrogen. Another important concept is the mole, which is the unit that is used in chemistry to express the amount of one substance, and 1 mole of any substance contains the Avogadro numbers of entities. The Avogadro number corresponds to 6.0.22 by 10 by 23. So it's a very large number of very small entities, because we are talking about molecules, atoms. This is a very important number if you want to take a mathematical approach. But today we don't have much time, and so if you want, we can talk about it in the future. But this is a very complicated operation to do, because you have to be aware of a lot of things that can happen inside your nutrient solution. There are reactions that may happen between the different salts, and it is very, very, very difficult. But luckily, nowadays we have the possibility to use software that will automatically calculate for us the best nutrient solution for our crop. There are several software that you can use. Today we will present HydroBuddy, which is a software that has been realized by Daniel Fernandez, and it is a very simple tool that you can use for the preparation of your nutrient solution. So now I'll show you. Okay, so this is HydroBuddy. Sorry, let me. Okay. So this is the main. I cannot make it bigger than this. Can you see it?
It's not that easy to read, actually.
I'm very sorry, but there is not a possibility to.
You can zoom your screen.
You can zoom on Teams. Can you read it now?
Yeah, yes. For everyone, on the left bottom of your screen, there is 2 symbols, the minus and plus. If you press the plus, it will work.
Thank you very much, Ismini. Okay, so basically this is the first window of the application, and here we have 4 different windows. We start from the welcome. In this window, you have other windows where there is the complete explanation of how to use it. But today I'm here for you, and so I will explain it very easily. And so let's start from the main page. So starting from the left column, here you have to insert the values of each element that you want to provide to your crop. So you have to look into the literature or into scientific publications and find which is the correct ratio of nitrate, of ammonia, of phosphorus for your crop. So for example, in this case, we will have 210, the unit of measurement here is expressed in ppm, so part per million, which is the same of milligrams per liter, if you remember from the last week. So now you will insert all the values for each element. And then, but you can also do this. Here you have in these 4 lines, you have the possibility to or create a new nutrient solution. So for example, here we have 50, here we have 180, and then we continue whatever, and we press on add formulation to database, and it will save it with the name that you press on the top. Okay, so the next time you will come back, you will have it saved on your database. Instead, if you already have one nutrient solution saved in your database, you can go in select formulation from database, and then you can choose between the ones that are already prepared from the software. For example, the Ogland solution is very frequently used for lettuce and leafy greens. Otherwise, there are specific nutrient solutions for other crops, like fruit crops, for example, pepper. You press it, and automatically it will appear in the column of the target concentration, which are the values that you want. And then you have to select the substance that you are using to prepare your nutrient solution. because you will not be using directly nitrate, but you will be using salts that contain nitrate, as we were saying before, for example, magnesium nitrate, calcium nitrate, or whatever. So you press on substance selections. And here on substance database, you have several salts that are already inserted. And here on the top, it tells you the concentration of each element. Otherwise, if you want to add another salt that is not present in the database, you can press the new. You can input the name, for example, magnesium nitrate. You can put the concentration, let's say that it is 30 of nitrate and 40 of magnesium. And you add it to the database, and you will find it here in the substance database. Now you have to select the ones that you are using, so the salts that you have available, and you press on Add to Used, and you will see that it will appear in the substances that are used for calculation. You will find, you will add all the substances you have available, and then you just close the window. After doing so, you have to select to decide the amount, the volume of nutrient solution you want to prepare. So in this case, we say 100 liters of nutrient solution. The concentration units, I suggest you to leave always ppm, part per million, and to leave always grams here in the mass units. In here, you can decide also to make to have the software to prepare for you or a direct addition salt preparation, or to prepare the salts for a concentrated A plus B solution. We use this only if you change the nutrient solution once a week, or if you have the possibility to have two different tanks, because very often salts like phosphate, sulfate can react with other salts like calcium. And if they react, they will precipitate and will no more be available to your plant. So now let's say that we do not have two tanks, we have only one. So we press on direct addition. And then we carry out our calculation. Now, if there is any error, the software by itself will tell you through these windows. For example, there is another possibility that is to select a fixed weight for a salt. For example, in this case, I was using a fixed weight for potassium sulfate, and I forgot to remove it, so now we have it. Also for this other salt. And now it tells you that ammonium monobasic phosphate is not used, so you can also remove it to obtain a better solution. The same for potassium monobasic phosphate. And then it tells you that there is a gross error on phosphorus that is too high. This is due to the fact that we do not have too many salts available. And so the software, in order to create a good balance that will never be perfect, will make some errors, but it will tell you immediately which are the errors. So then you can come back, select a fixed weight for the salt that contain phosphorus, decreasing the amount, in order to see if changing it, you can arrive to a better nutrient solution equilibrium. Okay. So after you do this, it will tell you that the calculation has been carried on successfully, and you go here. First of all, it will tell you the results nearby the target concentration column. And you can see immediately that the values are not perfect. So for example, as it told us, there is too much phosphorus in our nutrient solution. It can be good, it can be bad, because there is a tolerance level for the crop. So for example, if it was 45 ppm instead of 40, it is not a problem. But to have 200% the amount of phosphorus that is required by our crop, probably it is too much and can stress our plants. So probably we will have to carry out other calculation in the future. However, now let me move to the results page. And here in the first tab, you can see the recipe, the final recipe of your nutrient solution. So in the first column, you have the name of your substance. In the second column, you have the formula. In the third, you have the amount in grams. And in the end, you have also the cost of each single salt that is applied to our nutrient solution. Another very important thing that we must look in the result page is this tab on the bottom. In particular, if you have a look to the GE column, you see that there is a percentage that is regarding the amount of each element in regard to the target concentration. So for nitrate, we have the perfect concentration, so we have a 0% of error. Instead, for potassium, we have 100% more than what it's needed. Here, in the end, we have the predicted EC value, and we can also play with this. So, for example, 2500 is a very high electroconductivity level that can be used only for a few crops like tomatoes and other fruit crops, but you can play and you can also decrease the amount using plus and minus. You see here it's decreasing. And you have then to be careful because it will change also the relative amount of each single nutrient, each single element. Okay, this was HydroBuddy. I hope you understood how it works, and I suggest you to download it and to start playing. And if you don't understand something, you can also have a look here to the welcome page where there is everything explained. If you have any doubt, however, you can contact me at the email that you can find at the end of the presentation. Oh, sorry. So going back to our presentation. Now we will talk about the deficiencies and toxicities that we can have, can occur to our crop. So deficiencies and toxicities. Deficiency, we are talking about deficiency when there is not enough of one nutrient or more nutrients, and toxicities when there is too much of one nutrient that is stressing the plant. First of all, we need to make a distinction between mobile nutrients and immobile nutrients because the nutrients inside the plant can be mobile or immobile. This is a very important concept. For example, nitrogen is a mobile nutrient, and so the plant can move nitrogen inside its organism, so inside its tissues. And in fact, if we have a nitrogen deficiency, you will see that the symptoms will be seen, first of all, in the lower part of the canopy, so in the older leaves. This because it is a mobile nutrient, and so the plant is moving nitrogen from the older leaves to the new ones. And so the symptoms are occurring on the lower part of the canopy. Instead, for immobile nutrients, for example, iron, the symptoms are occurring on the top of the canopy, especially near the meristem, so nearby the apical part of the plant, because the plant is not able to uptake the iron from the older leaves. And so when the new leaves are born, there is no iron available for their formation, and so the symptoms will be occurring on the top part of the canopy. Another thing that we need to discuss is chlorosis and necrosis. These are the two most frequent symptoms that are connected to deficiencies and toxicities. We are talking about chlorosis. If, as in the left image, you can see the plant start showing yellow symptoms on the leaves, or a pale yellow, pale green color. Instead, we are talking about necrosis when there is the death of the tissues, so when they are drying and they die completely. Okay, so now let's see for each element which is the deficiency that can occur. So for nitrogen, we have the yellowing of the lower leaves, as we were saying before. that will lead also to a stunted growth, so the plant will be slow in growing, and a delayed in flowering and fruiting. And also there may be the drop of fruits and flowers. For phosphorus, instead, the symptoms are very easy to get because the plant will show purple or reddish leaves. This can be also confused because in some crops, like in strawberries, as you can see in the bottom right image, nitrogen deficiencies sometimes in some crop can be red or purple, depending on the type of crop. This depends on the type of crop, so you need to know also which is the behavior of your crop. This is very important because depending on the type of crop, the symptoms can be different. Also in this case, we will have stunted growth and reduced flowering and fruiting because we will have the drop of the flowers. For potassium, also the symptoms are quite easy to get because we have, first of all, the yellowing of the margin, as you can see in this eggplant on the top left image, that then, in the most severe deficiencies cases, can turn also into necrosis of the margins of the leaves. This also will lead to stunted growth, but also to a weak stem that can crack very easily. Calcium instead can lead to different kind of symptoms. The most known is the one that is occurring in tomatoes, that is the blossom end rot, where we have the bottom of the tomato, which is becoming brown and that is no more saleable. But for example, in lettuce, as you can see, there is another type of symptoms, which is the tip-borne. So you have the margin of your leaves that is curling and going in necrosis on the top part. Instead, in other crop, the typical calcium deficiency, you can see it on the leaves, and it occurs in browning or death of new leaves and growing tips. For what concerns magnesium, it is very easy also to get the deficiency of magnesium because it will occur in the intervenial part of the leaf. So as you can see, the veins are still green, but the intervenial part is starting to yellowing. This is a very clear symptom of magnesium deficiency. Another easy symptom to get is the leaf curling or capping. Sulfur, instead, it is an immobile nutrient, so the symptoms, as you can see in this image, are showing on the top of the plant, and it is showing as a yellowing that will lead to stunted growth and a delayed flowering. Iron has got symptoms that are very, very similar to sulfur deficiency. So if you have yellowing in the top part of the canopy, especially in the tip of the meristem and in the tip of the meristem, in the tip of your plant, in the apical part, it's very difficult to see if it is iron or sulfur. In this case, you should check the pH because the pH, of course, can be related also to deficiency because if the pH is not in the right range, then the nutrients are not available for the plant, and both iron and sulfur are available if the pH is acidic. So if it will increase, then they are no more available. Boron, instead, will lead to leaf discoloration and limited flower and fruit formation, and also to a fragile plant structure. And you can see it that the main symptom is the death and necrosis of the apical part of the plant that is completely dead. Manganese, it's not very frequent to have deficiencies in manganese because it is a micronutrient, but can be misled with magnesium deficiency. Zinc is also a micronutrient that leads to necrosis. And here we have a wonderful tab that you can use for the detection of deficiencies if you have any doubt. To use this tab, you have to start from the top. You have to see, first of all, the location of the deficiency. So if it is in the top or lower part of the canopy, if it is on the top, it means that it is an immobile nutrient. Instead, if deficiency is on the bottom part of the canopy, it means that it is a mobile nutrient. Then you can follow here the map and see if answering to the question, for example, the effect is mostly generalized. No, then in this case, you have to follow this part of the tab. Instead, if it is yes, you go further and follow here. This is a very useful tab that you can use. You can download it from the presentation. The presentation is blocked, is not going. However, we are done. Thank you for your attention. If there is any question, please. Here is also the email. If you have any doubt, you can write me. I hope everything was clear.
Any questions?
Oh, please.
Yes, thank you for the presentation. The software is for free?
Yes, it's for free.
Yeah.
Hydroponic.
Yeah, it's for free. You can download it. You just write hydroponic download. Maybe I can also put the link in the chat. However, there are also other tools. I think this is one of the best because it is very simple to use, as you have seen, and it tells you all the errors you can do. So it's very easy to use.
Not everyone is able to go into the chat, so I think.
Okay, put the link in the chat. I don't know if you can see it.
If possible, if you could share it when you share with us this recording with the email that we're going to receive, that would be great, because actually not everybody has
Access to the chat.
yeah.
Okay. Okay.
Thank you.
Perfect.
Amazing job, by the way.
Thank you very much. However, if you want, we can organize also other presentations. If you have anything you want to clarify or to get more in deep, you can organize. There will be other presentation from other guys of our research group in the next weeks. But after, we can do also some other in-deep presentations.
But I think from time to time you have to adjust the chemical composition of your material, because at some point it won't be the same concentration all the time. I mean, the stock at the beginning is different than in 3-4 years, maybe if got affected by oxidation or some other factors that could affect the chemical composition of the fertilizers, unless you keep just tracking it every day. This is my thought.
Well, actually, my suggestion is that you change your nutrient solution in the tank at least once a week. So you prepare the nutrient solution for 1 week of running your hydroponic system in order to finish it in 1 week, clean all the tank, because there will be some sediment, there will be some bacteria that is forming. And so to avoid also the clogging of drippers or the best functioning of the pumps, it's better to clean all the tank, but especially this is done in order to avoid the precipitation of the nutrients, as you were saying, because if you're not using 2 different tanks to separate phosphate and sulfate from calcium, for example, the more they remains in contact, the more they will precipitate. So to avoid this, we use 2 different tanks, or we replace the nutrient solution as more frequent as we can. This is my suggestion.
Okay. Thank you.
Thank you.
there are not more questions, I think we should move to the other meeting link group.